Hi and hello to everyone. In this video, we are going to discuss about the application of Laplace transform in solving integrodifferential equations. Welcome to the lecture. See, the main application of Laplace transform is to convert the time domain signal to a frequency domain signal. That is, x of t is converted to capital X of s. This is the convention. In time domain, we will use the small x. In the frequency domain, we will use capital X. It's a function of t. This is a function of s. S is nothing but j omega. S is nothing but the j omega, where omega is the angular frequency. This is the definition of Laplace transform, right? So if we have a signal in time domain, if you multiply with e power minus st, then integrate from time from minus infinity to plus infinite, we will be getting x of s. That is the Laplace transform of x of t. This is called two-sided Laplace transform or bilateral because the time is from minus infinite to plus infinite. You can mostly for solving differential equations, this x of t would be applicable for the time of positive quantity, right? So in this case, this x of t will be getting reduced to instead of minus infinite to plus infinite, we can change it from 0 to infinite. In such case, it is called as one-sided Laplace transform or unilateral Laplace transform. Okay. And these are the what I can say, straight away the conversion from time domain to frequency domain, right? If x of t is the signal, corresponding Laplace transform is x of s. If I differentiate once, x of t is differentiated once, it becomes s times x of s minus x of 0, right? And if it is 2 times differentiated, s square x of s minus s times x of 0 minus x dash of 0. Okay. Similarly, I can say for 3 times differentiation, you get extends like this. You can extend it, keep on going like that, right? And remember, these are the initial conditions. These are the initial conditions. What are the initial conditions? This x of 0, you can clearly see small x stands for time domain. For time domain signal, this x of t, if I substitute at time t equal to 0, I will get x of 0. Okay. Then this is x of 0. What is x dash of 0? X dash of 0 is nothing but it is again in the time domain. It is again in the time domain. dx of 0 by dt. Okay, this is also this shortly noticed as x dash of 0. Both are same, right? Okay. Then what about the integration? Integration is converted to 1 by s. If we integrate, it can be said as 1 by s x of s, right? If all the initial conditions are 0, means your x of 0 is 0, x dash of 0 is 0, even your x double dash. What is x double dash? X double dash in the same way I can say as d square x of 0 by, okay, this is your x double dash, right? So again I repeat, these are all the time domain representation, initial condition in time domain. If all the initial conditions are 0, our problem becomes very simple. 1 time differentiation is multiply with s, 2 time differentiation multiply with x square, 3 time differentiation multiply with s cube. But with initial conditions, our problem becomes a bit challenging, right? Okay, and this is the, for integration, it is multiplied with 1 by s. For differentiation, we are multiplying with s. For integration, we are multiplying with 1 by s. Now this is the first problem we are taking. So this is a differential equation, right? Okay, and the initial conditions are clearly given. X of 0 is 1, x dash of 0 is minus 2, right? So straight away, using the relation we have seen in the previous slide, we are just rewriting this as this, and dx of dt can be written as s x of s minus initial condition. Okay, right? Then 8 times x of t is 8 times x of s. This 2 u of t is nothing but the unit step function. Unit step function meaning is for the positive time it is 1, right? For the positive time it is 1. So for that the corresponding Laplace transform is 1 by s. So for u of t the Laplace transform is 1 by s. Now you plug the initial values here. Okay, for x of 0 you plug it 1, for x dash of 0 you plug minus 2, okay, plus 2. Similarly you plug the value for x of 0, you substitute 1, it's become minus 1 here, right? Okay, then it's all about the simple mathematical manipulations, right? What I'm doing here is I'm taking x of s from this term, from these 3 terms. Okay, so what is remaining? We have s square plus 6s plus 8. Now what are the other terms? Minus s, so we have plus 2 and minus 6 here. So plus 2 and minus 6 gets reduced to minus 4. Okay, bring this minus s and minus 4 to the right side, it becomes plus s and plus 4, right? Then it can be written like this, 2s square plus 4s by s. Bring this term, the left hand side term, to the denominator in the right hand side, we get like this, right? Okay, now we have to take the partial fraction. Okay, we are taking the partial fraction. We have three simple roots, right? So we can one is a by s, another is b by s plus 2, another is c by s plus 4. Okay, then you can cross multiply. Okay, we will be getting expression like this. You cross multiply, right? Okay, so a s plus 2 in times s plus 4, b you multiply with s and multiply with s plus 4. For c, multiply with s and multiply with s plus 2. Okay, so the entire denominator in the both the sides will be getting cancelled. Okay, so we have the only this numerator on both the sides. Okay, now our objective is to find the a, b and c, the constant. For solving a, I need to cancel out b, right? So if I put s as 0, your b and c are cancelled out. Okay, right? So substitute s as 0, we'll be getting a as 1 by 4. Similarly, to solve for b, what I have to do? To solve for b, you substitute s as minus 2. If you put s as minus 2 plus 2, it becomes 0. Here if you put minus 2 plus 2, it becomes 0. So a and c becomes 0, only we will be having b, right? Only we will be having b. Now on solving, we should be getting b value as 1 by 2. Next, to solve for c, what I have to put? To solve for c, I have to put in place of s minus 4. So minus 4 plus 4 becomes 0, minus 4 plus 4 becomes 0. So a and b will become 0, we will get only c value. On solving, you should be getting c value as 1 by 4. Okay, once you got your a, b and c, what do you have to do? Just you plug it in the x of s. Taking inverse Laplace transform, you should be knowing these relations, right? One is for u of t, the Laplace transform is 1 by s. For inverse Laplace, for 1 by s, the inverse Laplace is u of t. Similarly, e power minus a t u of t, the Laplace transform is 1 by s plus a. The inverse Laplace transform is for 1 by s plus a, the inverse Laplace transform is e power minus a t u of t. Okay, so look at this expression, is 1 by 4 multiply with 1 by s. So for 1 by s, the inverse Laplace is u of t. Here 1 by 2 multiply with 1 by s plus 2. So I can write e power minus 2t u of t. Right? So 1 by s plus 4 I can write it as e power minus 4t u of t. Right? So this is the solution of the given differential equation. Okay. So what you have done is, in between the time domain, we started in time domain. The question is in time domain. In between we convert things in frequency domain. Then that is by taking Laplace transform. By taking partial fraction, after that we are taking inverse Laplace transform, getting the result back in time domain. Okay, so the question is in time domain, the answer is in time domain. In between only we are working in Laplace domain or frequency domain, I can say. Clear? We look at another problem, very similar to this problem. Okay, and the initial conditions are clearly given, right? Okay, x of 0 is equal to 4, x dash of 0. What is x dash of 0? It is nothing but dx of 0 by dt is 3. Right? Again rewrite this 2-time differentiation like this. Then 1-time differentiation is written like this. Right? Then x of t is x of s. Then plug the initial condition values. Remember, if the initial conditions are 0, this part will not be there. This will not be there. This will not, both are, this is 0, this is 0, this is 0. Our question becomes very simple. Okay, right? So it's just we are proceeding. Okay, I hope you can follow. You can pause the video and you can take notes if you wish. Right? Then ultimately you have to take partial fraction. Okay, we are taking partial fraction. Solve for a, b, and c. Solving a, b, and c. A you are getting as 5 by 2. B you are getting as 6, C you are getting as minus 9 by 2. Okay, taking inverse Laplace, we will be getting the answer back in time domain. Right? Now, third problem. This is another differential equation, but we have an integration. This is an exact integral. You have the integration as well as the differential equation, right? So it's very simple. The initial condition is given. Okay, the solution is find y of t. Find y of t. That is what required. Y of t is what needed. Okay, so we are taking Laplace transform. We are taking Laplace transform. We are taking Laplace transform. Right. So for the first term, dy of t by dt, it is s times x. It is s times y of s minus y of 0. Then for phi y of t, it is phi y of s. Here your integration is converted to 1 by s y of s. Your u of t is converted to unit step function. Further, the Laplace transform is 1 by s. Right. The only thing is, if you have an integration here, for instead of integration, I am replacing with 1 by s. Your y of tau is becomes y of s. Clear? Then it's as usual. The previous problem, we are taking y of s out from these three terms, right? Y of s, y of s, y of s, y of s, right? So what is remaining? We have s, we have 5 from here, we have 6 by s from here, then we have only minus 2 here. So bring minus to the right side. You can write this in 1 by s plus 2. You can write as 1 plus 2s by s. Okay. Okay, so these 2s gets cancelled, right? Bring this term in the left hand side to the denominator. It becomes like this. For taking partial fraction, we are splitting this into s plus 2. This can be written as s plus 2 and s plus 3. Okay, so it is a by s plus 2 plus b by s plus 3. Solve the partial fraction. Okay, if you substitute, as usual we did in the previous problem, if you put a ss minus 3, we have to solve it, right? I have not given the complete solution. If you solve, you will be getting as minus 3. If you solve bs 5, you substitute here, take inverse Laplace. This will be your solution. Okay, right? I hope you learned something useful from this lecture. Thanks for listening. Wish you a happy learning.